Just as we saw for strings, processing offers us a bunch of built-in tools for manipulating p-vectors. To apply one of these operations to a p-vector, we use the same syntax we used with strings. For example, suppose we have this p-vector, pv. I'm going to actually create it by calling new p-vector and giving it the starting values 3, 5. To apply an operation to this p-vector, first I name the variable, here pv, followed by a period, then the name of the operation I want to apply, an open parenthesis, any arguments it takes, and then a closed parenthesis. Even if the operation takes no arguments, we still need the open and closed parens. The period that occurs between the variable name and the operation can't have any spaces around it. So you want to type things in just this way. The variable name dot the operation name and then the arguments between parentheses. Let's take a look at some of these operations. To illustrate these, I'm going to assume we have two p-vectors, and I'll write them here in red so that they're easy to pick out. They're named A and B. We've seen that before we can do anything with either of these variables, we have to actually create the p-vector by saying something like A equals new p-vector 0, 0. Let's assume that p-vectors A and B have already been created, and we just want to change the x and y values, say in vector A. We do that with the set routine. So we call it by saying a.set, which tells processing take the object A, here a p-vector, and run the function set for A. Set takes two arguments, the x and y values, and it assigns them to A. So this one line is the very same thing as these two lines, a.x equals 3, a.y equals 4. It just saves you a line of code. But remember, A must already exist. If you haven't called new p-vector yet, you'll get an error because you're trying to set the values of A before A exists. If you want to copy the values from B into A, here's what we want to do. We want to say b.get. That gives us back the elements inside of B, and then we can assign them to A. So this one line is just the same as typing these two lines. You might be thinking to yourself that this seems like a roundabout way of assigning B to A. Why don't we just do a normal assignment like we always do? A equals B. It turns out that because of the way processing stores p-vectors, you don't want to do this. This is going to give you some weird results. If you want to copy the values from B into A, call b.get and assign that to A. I like using these routines because they make it harder for me to make a silly error like writing a.x equals b.x, a.y equals b.x. So I stick x into both a.x and a.y. I make those kinds of typos all the time, and they take forever to track down and fix. If you call b.get, there's no confusion. You can also add, subtract, multiply, and divide two vectors together. To illustrate that, I'll use two p-vectors A and B and a floating point number f. To add two p-vectors together, we use the routine add. So in this syntax, we're saying take B and add it to A. So typing a.add with B as an argument is the same thing as typing these two lines. Take the values of B and add them to the corresponding values of A. Well, of course, if we can add, we can subtract. And so sub simply subtracts B from A. We can also multiply and divide. Those work with a single floating point number. So if I say a.multf, where mult stands for multiply, that says multiply both x and y by f. And of course, if we can multiply, we can divide. So if I say div f, then both x and y get divided by f. Keep in mind that mult has 4 letters, while add, sub, and div have only 3. I really wish mult was just mul, and then everything would be 3 letters, but that's not how it is. There are a couple of really great geometrical shortcuts that you can pull off with p-vectors. Suppose that we have a point A somewhere on the screen, and we want to know the distance between A and the origin of the coordinate system. Let's call that f. To find that distance, all we have to do is call a.mag. Mag stands for magnitude, and it just tells us the length of the arrow from the origin to the point A. That's great. We don't have to mess around with square roots and squares and Pythagoras' rule. Just call mag and you've got the distance. Well, often we don't want the distance to the origin. We want the distance to another point, and we can do that too. So if we have a point A and a point B, and we want the distance between them, which again we'll call f, all we have to do is call dist. A.dist with the argument b gives us back the distance between A and B. Of course, if I swap the order and I called b.dist A, that's the same number because the distance from A to B is the same as the distance from B to A. So mag and dist are great. Be aware that they can take some time. Under the hood, when they run, they both have to do a square root, which can be a time-consuming operation. So if you use a lot of calls to mag or dist in your program and it seems to be running slowly, that's one place to look for opportunities to speed things up. If you're into advanced geometry, then you'll appreciate a few additional function calls that are built into the PVector. I'll talk about them here very quickly just so that you're aware that they're out there. If you like to find the dot product or the cross product of two vectors, both routines are available, and of course they're named simply dot and cross. If you want to normalize a vector, that scales it so it has a length of 1, and you simply call normalize. You can also call limit, which says if the vector is bigger than some number I'm giving it, scale it down so it's only as big as that number. Finally, if you have two p-vectors, you can call angle between to find the angle between them. These are kind of advanced ideas, but they're very handy in some situations. Let's recap the operations we've seen on p-vectors. First, we have set and get. Set lets us put x and y values into a p-vector in one call, but remember the p-vector has to already exist. Get is the way that we copy from one to another. Never assign one p-vector to another because your program will start to work strangely. Instead, use get. The second set has to do with math. We can add and subtract two p-vectors, and we can multiply and divide a p-vector by a float. The third set were just kind of useful geometric tools. We have mag that tells us how far a p-vector is from the origin, and dist that gives us the distance between 2 points. You're probably going to end up using dist a lot more often than you use mag. And then finally, for the folks who like advanced geometry, there were a bunch of advanced calls to let us take the dot product, the cross product, normalize a vector so it has a length of 1, limit it so it's no larger than some value, and angle between that lets us find the angle between two vectors. These tools are great, and I strongly advise that you use them whenever possible rather than manipulating the x and y values yourself. Using these routines, your code will be easier to write today. It'll be easier to read and figure out what it does when you come back to it tomorrow, and should something go wrong, it'll be much easier to fix.